Here we are, Calc1, Day 7, Lesson 14, Chapter 2, Section 6. This is Doc again. Today we're going to look at implicit differentiation. Sometimes we'll have an equation, for instance, this circle. Okay, and we want to differentiate it, but we see a y squared in there. Now what we can do sometimes is we can solve for y. And in this case we could. We could take the x squared over here. And then we could take the square root of both sides. And we could split it up. And differentiate, okay? That's a lot of work. So there is another method that once you get the hang of it, it's quite simpler, and it's called implicit differentiation. And the key of implicit differentiation is realizing that dy dx of y is y prime. So when I differentiate y, I will get y prime. So let's take a look at our circle again. This is example 1 on page 158. And I have x squared plus y squared equals 25. And the problem says to differentiate it first, then find the equation of the tangent at point 34. Okay, so we're going to be looking at point 34 for part B. All right, part A. First, differentiate. Now, when I differentiate using implicit differentiation, I'm just going straight across. So I have 2x plus, because I'm differentiating with respect to x. Now, when I get here, there isn't an x. So this is a function of x in here. So I'm going to differentiate it by using my power rule, 2y to the first, and then the chain rule, differentiate the inside, y prime. Okay? So again, to note over here, whenever I differentiate y squared, I'm going to take 2y to the first using my power rule, but then I'm going to also differentiate y, and I told you that when you differentiate y, you get y prime. Okay? So differentiate 25, I get 0. All right, now we're going to solve this for y prime, so I'm going to move my 2x over. And then I'm going to divide by 2y. And when I do that, I will have y prime equals reduce negative x over y. Okay, so this is my formula for slope now. So if I want to figure out what my slope value is at 0.34, because I'm looking at 0.34, I used to just plug in the 3 for x. Well, now I have an x and a y, so I plug in both. So that would be y prime negative 3 over 4. Okay, negative 3 over 4 at 0.34. Now, the second part of the question is to write the equation of a tangent line. We have our point, we have our slope, so let's do that. So here we go, y minus y sub 1, and then we have x minus x sub 1. Okay? Now, I'm going to clean this up a little bit. So I have y minus 4 equals negative 3/4 x plus 9/4. So that would be 4y minus, I'll go ahead and multiply that by 4, 16, equals 3x plus 9. And when I bring my x over to this side, 3x plus 4y, bring my 16 over to this side, equals 25. That is my equation of my tangent line. Example 2 is kind of a neat graph. It's called the folium of Descartes, right here. Comes up, comes around and down. And this example is an example that you cannot solve for y and use your old method. So we have x cubed plus y cubed equals 6xy. Okay? Now, if I differentiate this, which is the first thing, find y prime, I go straight through and I have 3x squared plus 3y squared y prime equals, now, and again, 3y squared y prime, and over here I have product rule, so that would be 6x, differentiate y is y prime, plus leave y alone, differentiate 6x, and I get 6. Now I want to move all of my y primes on one side so I can solve for y prime. So I have 3y squared y prime, bring this over, minus 6x y prime equals, take my 3x squared over, negative 3x squared plus 6y. And factor out my y prime. Divide. And after I do that, I'm going to see that I can reduce this because it all has factors of 3. So I'm going to factor out my 3 and reduce. Once I do that, I will get simply negative x squared plus 2y over y squared minus 2x. Okay? All right, so now the question is, find the tangent at point 33. Okay, so here at point 33, find the tangent. Now it's giving me x1 and y1, both is 3. So when I come in and I substitute these in, I have my y prime equaling, I'm going to reverse this, so it says 2y minus x squared over y squared minus 2x. Okay, plug in 3, 2 times 3 minus 3 squared, all over 3 squared minus 2 times 3. All right, so this will be 6 minus 9 over 9 minus 6. On the top, negative 3, bottom positive 3, so I have negative 1. So that is my slope at that point. So now that I have my slope and my point, I'm going to use the point slope formula. So again, y minus y sub 1 equals slope x minus x sub 1. So y minus 3 equals negative x plus 3. All right, so now I'm going to move my x and y on the same side, put it in standard form, equals 6. Now you might say, well, how do I know what form to put it in, standard form or slope-intercept form? Well, usually if you're not told, you just put it in standard form, but slope-intercept form would be fine as well, okay? So before we go on to part C, let's take a look at that curve. You can see here is the tangent line. has a slope of -1, makes sense, right, coming down through there. All right, part C. The tangent line is horizontal if y prime equals 0, so we want to find in the first quadrant, where is the tangent line horizontal? So that means I have to examine my first derivative and we can use a little logic here and realize that it will be 0 when this numerator is 0. So I'm going to ask myself, when is that? And I'll solve for y. Well, it's going to be positive. Watch when I move things from left to right. Divide by 2. Okay, so it looks like it's going to be 0 when y is equal to 1/2 x squared. So what do I do with that? Well, I want to know where, so if I want to know where, I just go back and I plug this into my original equation. Okay, so I have x cubed. I'll write the original equation here real quick. X cubed plus y cubed equals 6xy. Okay, now plug this in to find out where that would be. X cubed plus 1/2 x squared to the third equals 6 times x times 1/2 x squared. I'm going to have x cubed. I have a feeling I should have started on the next page. This is 1/8 x to the 6th. And if I reduce over here and combine these, equals 3x squared. No, x cubed, thank you. X cubed. Let's just take everything to one side first. -2x cubed plus 1/8 x to the 6th equals 0. If I multiply everything by 8, I will have -16x cubed plus x to the 6th. I have now -16x cubed plus x to the 6th. I'm still solving for where this is 0. If I have x to the 6th equals, move this over, 16x cubed, and then I divide by x cubed, that will give me x cubed equals 16. Then I'm going to take the cube root of both sides, and x equals the cube root of 16. Again, what I said is if I have the cube root of 16, that can be the cube root of 8 times 2, which is 2 cube root of 2. Okay? And it might be easier to deal with if I just leave it in this form for now. I can see that my tangent line for my x value is 2 cube root of 2. I go back and solve for y. So I want to solve for y. My x value was cube root of 16. We're going to leave it that way for now. And there's other forms. If you want to break it down to 2 to the 4th and say 2 to the 4/3, that might even be a nicer form to deal with it, because 16 is 2 to the 4th, so it's 4/3. Let's take a look at that way and go back and remind ourselves that y equals 1/2 x squared. So when I plug my x value in to get y, I have y equals 1/2 2 to the 4/3 squared. So we have 2 to the 8/3 here. Okay, 1/2 2 to the 8/3. And remember that 1/2 is actually 2 to the -1 power. So that's 2 to the negative 1 power, and I have 2 to the 8/3 power. So if I use my laws of exponents, negative 1 is 3 over 3. So I'm going to add my exponents, and I get 2 to the 5/3. Find y prime if sine of x plus y equals y squared cosine x. Okay. Now, again, differentiating straight across is what we're going to look at here. We can see that I'm going to have to use my chain rule. Over here, I have a product function, so I'm going to have to use that as well. So let's take our time here, and I'm going to actually go straight across. So this would be cosine, because the derivative of sine is cosine, x plus y. And then I'm going to differentiate the inside. And when I do that, I always make my parentheses bigger so I'm not mistaken that it's under here. Differentiate x, I'll get 1 plus differentiate y, y prime. Okay? So that is this side. Now let's move to the other side. I have a product rule here. Y squared, I'll leave it alone first. Derivative of cosine is negative sine plus, leave cosine alone, and differentiate my y squared, so it's 2y, y prime. So, not very nice looking at first, but we can clean this up a lot, and we're going to. So, let's take a look at that. I'm going to move this in the front. Okay, and this is cosine of x plus y. And this will be negative sine x. Well, actually, I should probably put the y squared in front here so that I don't get that again confused with the underneath the sine. So negative y squared sine x plus, all right, now this was cosine x and then times 2y, y prime. So this is 2y, y prime cosine of x. All right, and still not too nice looking, so I need to multiply this in to each one of these here. So I'm going to have cosine x plus y. I can't distribute this because this is just part of cosine. Plus cosine x plus y times y prime. I'm going to put the y prime in the front. All right, equals. Now I want to get my y primes on one side and my other terms on the other side. So I'm going to move my y prime over here. And I have y prime cosine of x plus y equals, oh, I'm sorry, got to move this over, minus 2y, y prime cosine of x now equals, I have negative y squared sine of x, and I'm going to move this over. So minus cosine x plus y. Whew, getting a little crowded over here. Okay. All right, factor out my y prime. I have cosine x plus y minus, factoring out my y prime, 2y cosine x equals, again, negative y squared sine x minus cosine x plus y. Now I can divide both sides by this. And when I do that, I will get this for y prime. Let's see how I did. I'm going to factor out a negative and then reverse these by factoring out a negative so that we can have less negative values because it just causes less mistakes. So y prime, when I factor a negative out of here and reduce it, I will get y squared sine of x plus cosine x plus y over, again, I'm reversing these two, so 2y cosine x minus cosine x plus y. Okay, let's see how we did. Looks good. All right, there's some interesting figures down here where we got some pretty crazy looking figures that we might need to differentiate. So figure 7, 8, 9 show 3 more curves produced by computer algebra system with an implicit plotting command. Okay, here we go. Here's figure 7, here's figure 8, and here's figure 9. So you can see how interesting those would be to differentiate as well. This one's really cool. Okay, we're going to look at example 4. And example 4 has finding y double prime if you have x to the 4th plus y to the 4th equals 16. All right, going straight across, first we have to find y prime. 4x cubed plus 4y cubed y prime equals 0. Solve for y prime. I'm going to subtract this over to this side. I have negative 4x cubed. Over here now, 4y cubed y prime. Solve for 4y cubed. And I have negative x cubed y cubed. Okay, so that is my first derivative. Now to do my second derivative, I take my first derivative and I differentiate it. So I have y double prime equals, that is a quotient rule. So I square the bottom, bring my y cubed up. And then I'm going to, and then I have to make sure I have my negative here. Okay. All right. And now I'm going to take my 3x squared and then subtract, because it's my quotient rule, x cubed and 3y squared y prime. Now this is a bit of a mess. So I have a y prime here and a y double prime here. So in order to solve, I'm going to have to plug in my y prime into my second derivative so I can simplify it a little bit better. So I have, again, this is negative in the front, y cubed 3x squared minus x cubed 3y squared, and this is negative x cubed over y cubed. Okay, now this will make this positive. So let's take a look at what I have here. 3x squared y cubed. This is now going to be plus. I'm going to do some reducing. And I have 3x to the 6th all over y. Okay. all of that still over my y to the 6th, and I have a negative out front. Okay, well, can't leave it like that because this is a complex fraction here. So I'm going to have to get my common denominator, which is y. So multiply the top and bottom by y. And when I do that, I will now have 3x squared y to the 4th plus 3x to the 6th all over. When I do that, this will all be over y, and then I can invert and multiply, so that'll make this y to the 7th, and don't forget the negative out front. Okay, so now I can still reduce this. So it looks like I can take a 3x squared out of both of these. So let's go ahead and do that and see if that helps. 3x squared, that'll leave me with y to the 4th plus x to the 4th over y to the 7th, not forgetting that I have a negative here. Here I see that my y to the 4th plus x to the 4th should look a little familiar to me because that is what I started with at the top. So I can substitute 16 in for that, and I will have negative 3x squared times 16 all over y to the 7th, and that'll be negative 48x squared over y to the 7th. You can put the negatives now at the top or in the middle. It doesn't matter. And so that is the end of this lesson for implicit differentiation. I'll see you for the next one.